Hi everyone, today I'm going to talk about categorical features and dense embedding. Let's say we have a categorical feature color for our machine learning model. The easiest way to pass categorical feature for the model is to use one-hot encoding. It's when we pass 1 if it's our target category and 0 for everything else. For example, product color was red and we pass 1, and everything else we pass 0. That approach becomes quite inefficient if we have too many categories. For example, words, we can have thousands of words. And if we use tokens, even more, we can have 100,000 of tokens. And setting 0 just for one token and passing everything else as 0 would be quite inefficient. So for this purpose, we can use dense embedding. In contrary to this approach, we'll assign some vectors and use vectors of specific size to pass to neural network. For example, we assign three-dimensional vector for each of the color. And in our case, it will be nothing to do with an RGB representation. It will be at the beginning just random number that we initialize when we create a dense embedding. Now we randomly assign some values to each of the colors, and they do not represent anything yet. But when we start training the model, we also start adjusting the model weights during the training. How it works. This is our embedding layer. And let's assume that it connected just to MLP, multi-layer perceptron. When we do forward pass, and let's assume our color is red, we take this vector from our matrix and we pass it to MLP, and it will be dot 3, dot 4, dot 2. We calculate the value and we have the output, and then we can start calculating gradient and apply backpropagation. So we readjust weights in our MLP, and by chain rule we get to our embedding. So if the batch contains the category, we calculate gradient and readjust this vector. If the batch contains multiple occurrence of the same category, we'll average the gradient and adjust it. If the category is not in the batch, we don't touch it at all. So this value doesn't change. But over time, we'll touch all the categories, so hopefully we adjust all of them during model training. As a result of this training, categories that are closer to each other, they will appear in similar places close to each other in this multi-dimensional space. In our case, red is going to be probably close to purple, and maybe blue will be also close to purple, but blue and red will be quite on the distance. So like purple here, and we have red nearby, the same as blue. Why it's called dense representation? Because for each of the vector, we have a smaller but quite dense representation of this category. Despite we have quite a big matrix, we still do quite little operation because the first operation is just taking the index and loading the vector and passing into MLP. So the size of this vector is relatively small comparing to one-hot encoding when we had like a lot of zeros and only one value is 1. Also, we can reserve some indices for some edge cases like padding or missing values. For example, we can create one more category for missing value. So during training, we randomly remove some of the categories and instead we pass missing value. In our case is 5. And the model will kind of try to figure out what to do if it doesn't know what the category is. And if we train the model using this approach, in the future, if our database contains the new category, which was unseen, we just replace it with missing value and the inference doesn't break. Of course, it won't probably return the ideal answer, but at least it doesn't crash. That's pretty much it. Thanks for listening. Goodbye.